This is a presentation in IBM Watson Analytics Expert Storybook for the 2018 Watson Analytics Global Competition. My name is Sarah Agam, and I will present on behalf of teammates Mwali Mupiri and Justice Samoa from the University of Maryland University College in the United States of America. Effects of household air pollution. The use of solid fuel for cooking and heating expels household air pollution with damaging effects that span into health, ecology, and demographics. The household air pollution study is organized into 5 dashboards that demonstrate discoveries including demographics, health, ecological, and future effects. Effects of household air pollution study is intended to identify patterns and correlations that contribute to an understanding of the problem and identify areas of critical risk for intervention. Our data includes Institute for Health Metrics and Evaluation, which measures health and pollution exposure with a quality score of 74%. United Nations data measures household energy consumption, and World Bank data measures environmental emissions. The target for the study is household air pollution from solid fuels exposure. Worldwide view of household air pollution from solid fuels exposure 1990 to 2016. This discovery animates worldwide household air pollution. Regions in South America, Asia, Central Europe, and most predominantly Sub-Saharan Africa experience high household air pollution. Demographic effects of household air pollution. Household air pollution is associated with socio-development factors, including income per capita, educational attainment, and fertility rates. Drivers predicting household air pollution. Watson Analytics identifies top drivers to predict the target HAP. A two-way ANOVA test is applied for interaction effects of the variables. Each of the top 4 drivers includes socio-demographic index and/or region with predictive strengths from 82 to 89%. The top drivers guide the analytic direction of this study. Driver 1, demographics and region. Regions falling under lower demographic index exhibit higher household air pollution, as shown by darker shaded areas of the heat map. Highlighted areas found within the drill down for driver 1 indicate unusually low demographic index. These regions have the strongest impact, increasing the target variable. As shown on the right, the large brown bubble regions fall within a demographic index of less than 0.4. Driver 4 is demographics. There is an inverse relationship between socio-demographic index and HAP. As demographic index decreases, household air pollution increases, shown by darker shaded points in the scatter plot. The first key finding, household air pollution impacts lower demographic regions. The study will investigate the health and ecological effects of household air pollution in regions where occurrences are most prolific, Africa. Health effects of household air pollution. Harmful solid fuel pollutants expose vulnerable young children to respiratory illness. Respiratory mortality is a leading environmental cause of death for children under 5. Driver 2, region and under 5 respiratory mortality. Eastern and Western Africa are highlighted on the regional map with dark shading for HAP and large dark circles for under 5 mortality. Drilling down into the Western African region identifies countries with the greatest health effects from HAP, including Niger, Chad, and Guinea. Western and Eastern African regions in brown and green consistently account for over 40% of under 5 respiratory mortality throughout 1990 to 2016. Intervention to the 2 regions will have a profound effect on the issue. Driver 3, region and life expectancy. As household air pollution decreases, depicted by lighter colors, life expectancy increases, shown by size of box. While illustrating an association trend between declining HAP and life expectancy, the visual also identifies anomalies within the data that reflect outside causes of lowered life expectancy, such as an AIDS epidemic in Southern Africa. Drilling down into North Africa showcases severely reduced life expectancy for the 2011 Libyan crisis. While most of Northern Africa is less affected by household air pollution compared to sub-Saharan regions, the transformative effect of declining HAP is underscored in Sudan. As shades consecutively lighten, Health outcomes improve within large boxes of life expectancy. The second key finding for the study: the greatest health effect of household air pollution is under 5 respiratory mortality. Furthermore, household air pollution impacts life expectancy. Ecological effects of household air pollution. Around 3 billion people worldwide cook and heat with solid fuels, biomass, coal, dung, and agricultural remnants. The fuels expel pollutants such as particulate matter and greenhouse gases. Particulate matter. Particulate matter increases with household air pollution, shown in darker colors of the scatter plot, and correlates with under 5 mortality, shown by size of bubble. Polluting fuels. Crop waste, green on the stacked bar chart to the left, is the top polluting fuel in sub-Saharan Africa. Pollutant output from a study is uploaded into Watson Analytics to create a pie chart on the right. Crop waste expels the highest levels of particulate matter. Wood fuel use in Africa and deforestation. On the stacked bar chart to the left, wood fuel use has doubled in Africa from 1990 to 2015, causing a concern for deforestation. To the right, the emission of carbon dioxide increases as forest area decreases each year. Total greenhouse gases. There is an expectation that greenhouse gases increase with the burning of solid fuels. However, the data does not show a conclusive pattern. Trends of cleaner fuel use and household air pollution. Some fuels burn cleaner. Electricity is increasing in Africa on the left while decreasing HAP. The LPG gas trend on the right is less stable, but has an overall positive effect on reducing HAP. The trends support a need for cleaner fuels. Future effects of household air pollution. Areas of critical risk for household air pollution will be identified and monitored for intervention. Identify and monitor risk. Watson Analytics predicts household air pollution with chi-squared automatic interaction detection, or shade tree, and regression analysis based on a combination of drivers with a predictive strength of 91%. The top branch of the decision tree predicts household air pollution exposure as 80 for every 100 people. The critical risk group is delineated from moderate and low risk groups as data groups within Watson Analytics. The new column is fed into a map of critical risk for intervention. Countries in Afghanistan and Africa exhibit the most critical risk for HAP. Stove projects for intervention. Improved stove projects from the UN High Council and other organizations are monitored in Watson Analytics. A web page for an organization provides an opportunity for viewers to learn about the cause or donate. Social media for intervention. Social media provides a powerful platform to create awareness and education for household air pollution. A baseline of social media attention identifies only 3,001 total mentions from 2016 to 2018. Most mentions are in news and some are in blogs. Positive sentiment highlights cleaner fuel, and negative sentiment promotes the danger of solid fuel and effects. More awareness is needed to expedite the eradication of HAP. Trends and forecasts. The trend for HAP and under 5 mortality is in decline. The United Nations created a millennium goal to eradicate under 5 mortality by 2030. However, International Energy Agency and World Health Organization contend that the outlook will change little by 2030 based upon an expected increase in population for developing nations. A calculation for the percentage of change, weighted with 10 years for each value, is applied to the data to create a forecast. Household air pollution is predicted to end in 2083, indicated by brown bars. Under 5 mortality is predicted to end in 2030, indicated by a green line. Intervention will be required to achieve the Millennium Goal. Conclusions: demographic effects. Household air pollution from solid fuels exposure is disproportionately associated with lower socio-demographic development and lower life expectancy. Developing nations experience more effects. Health effects. Under 5 respiratory mortality, while in decline, continues to be the greatest environmental threat to vulnerable children. Ecological effects. Energy disparity leads to solid fuel use, which expels pollutants exceeding household air safety thresholds. Future effects. Interventions to critical areas will be required, to reduce damaging effects and help bring the issue within reach for eradication. Recommended solutions. Short-term solutions include awareness through social media and education. Stove project interventions provide improved stoves to induce complete combustion of solid fuels and properly vent pollutants from the household. Midterm solutions include reducing energy disparity with cleaner energy infrastructure for affordable access to LPG, biogas, and electricity. Carbon credits from developed nations can be applied to defray infrastructure costs for developing nations. Long-term solutions include green energy infrastructure with access to wind, solar, hydro, or geothermal energy. Thank you for viewing the IBM Watson Analytics Expert Storybook presentation on effects of household air pollution.